Okay, pre-calculus, homework lesson 14. This lesson is dealing with quadratics. That's when there's an x square. Remember that the parent function of a quadratic is y equal x squared. And the graph would look something like this. Okay? And we've already dealt with the parent function of a quadratic and all of that. Now, there's some stuff that we might remember, like the general form is y equal a times, in the graphing form, x minus h quantity squared plus k. That was the graphing form. And we dealt with those parameter changes. What's outside the parentheses happens to y in the order of operations. What's inside happens to x in the reverse order of operations. Remember that? So we would say if this is a plus, you're going to shift up. If that was a minus, you would shift down. If a gets bigger, the wings get steeper, so the parabola gets narrower. If a gets smaller, the wings get less steep, so the parabola gets wider. If that's a minus h, then we're going to think of it as a plus, and it's going to shift to the right. If it was a plus, we would think of it as a minus, and it would shift to the left. That's graphing form stuff. What we're dealing with here is standard form stuff. The standard form of a quadratic is y equal ax squared plus bx plus c. And what we want to know is our standard form rules. In standard form, if a is positive, what's going to happen? The parabola will open up, and the vertex is a minimum. Correct? If a is negative, it opens down, therefore the vertex is a maximum. We should know how to find the line of symmetry. Remember to find the line of symmetry from standard form. The formula is what? Well, what kind of a line is the line of symmetry? Vertical line. So the equation is x equals something. X equal what? Negative b over 2a, and that's using the a and b of standard form, right? These are standard form rules for quadratics, okay? To find the x-intercept, you let y be 0. To find the y-intercept, you let x be 0, and that's all the rules that we need to know. So we need to know that standard form is ax squared plus bx plus c. If a is positive, it opens up and the vertex is a minimum. If a is negative, it opens down and the vertex is a maximum. The formula for the line of symmetry is x is equal to the opposite of b over 2a. To find the x-intercept, you let y be 0. To find the y-intercept, you let x be 0. So we're going to find all of those things and then graph with just that, the best job we can do. Obviously, we can make the prettiest parabola we could make if we do that fancy table building stuff that we've already learned that came from my Algebra 1 book, page 195A. Okay, so here we go. We want the line of symmetry. It says show all work below, so we'll show all work below. To find the line of symmetry, we're going to have x is equal to the opposite of b. What's my b value? So we have the opposite of a negative 2 all over 2 times my a value of 1. opposite of b over 2a. The opposite of a negative 2 is a positive 2. 2 times 1 is 2. 2 divided by 2 is 1. So my line of symmetry is the vertical line, x equal 1. To find my vertex, what do I need to do? Now, what we did from page 195A is built the table because not only did we want the vertex, but we wanted some left wing points to reflect across and make some right wing points, but we're not really doing that there. We're just going to take our equation, y equal 1 times whatever x is, 1 square. We're plugging in right here, minus 2 times my x of 1, minus 8. We're going to plug x into the x positions in our equation and solve for y. So we're going to have y equal 1 minus 2 minus 8. And so y is equal to negative 9. And so my vertex, when x is 1, then y is negative 9. See how we got that? And I'm going to plot that. It's obviously on the line of symmetry, negative 1, 2, 3, 4, 5, 6, 7, 8, 9. It's down here. Sorry about that. I didn't slide it up quite enough. The vertex is a maximum or minimum. A is positive, correct? That means it opens up, therefore the vertex is a minimum. So our parabola is going to go up from there. To find the x-intercepts, we let y be 0. I'm going to clean out my work area. So I would let y be 0. So I'm going to have 0 equal x squared minus 2x minus 8. Now we have to remember something from the past. We have to remember how to solve a quadratic. We can solve by factoring. We can solve by using the quadratic formula. Now, let's talk about 2 or 3 things here because we need to review. If a is 1, then I can ask the question. If a is 1, then I can do this, correct? I can factor quicker. If a is 1, I can do that. And then I can say, what do you have to multiply? What can you multiply to get a negative 8 and add to get a negative 2? If a is 1, you go ahead and put your x's. And then you think, what do I multiply to get my c of negative 8, but add to get my b of negative 2? And the answer would be negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. The thing that I could the 2 things that I could multiply together and get a negative 8, but yet add together and get a negative 2 is a negative 4 and a positive 2. Now, if you can think that in your head, then you can do the ones where a is 1 faster. But you have to know sign rules, obviously. So you would stick those 2 numbers directly in there, minus 4 plus 2. If a is 1, you can think, what do I multiply to get my c and add to get my b? And if you can think of those, you stick them right straight in. Yes? No, it's correct. Multiply to get negative 8 and add to get negative 2. It's correct. Yeah. But thanks for asking. Now, if that's true, if these two things multiply to give you 0, then we could say that either x minus 4 equals 0 or x plus 2 equals 0. Okay? And then we solve each one. Plus 4, x equal 4. Minus 2, x equal negative 2. So my x-intercepts are 4, 0, and negative 2, 0. Let's see how we got that. Now, we also should know how to use the AC method or the quadratic formula. And as we continue to do problems in this worksheet, I'll do it with the different methods. There's no sense in doing it all three ways on one when we have a lot of problems to work from here on out. So I can plot those now. I can say to the right 4 from the origin, to the right 1, 2, 3, 4, 0. And I can say from the origin to the left 2, up or down 0. So there's my x-intercepts. You got that? So we had to use a little factoring to get that. To find the y-intercept, I'll let x be 0. So we're just going to stick that in place of x both times. And we would have y equals 0 squared minus 2 times x of 0 minus 8. When we let x be 0, that part gets wiped out, and we have y equal negative 8. And so the y-intercept is negative 8, which was right there. If you can see that down at the bottom, it's, yes, minus is from up here. So minus 2 times 0. We're just plugging into that. So 0 squared minus 2 times 0 minus 8. Now we're going to just graph, and we're just going to do the best we can to hit all that. You can see that my vertex is here, so it's kind of doing that and that. And I missed a little because I'm on the smartboard there. But we can get a decent graph of a parabola by finding its line of symmetry, vertex, the x and y intercepts, which are good things to be able to find. What's another word for the x-intercepts? What's another word for the x-intercepts? They're the solutions to the quadratic, right? If we were going to solve that quadratic, the solutions would be the x-intercepts. Okay? We also call those the zeros of the quadratic, the x-intercepts of the quadratic. They're the roots of the quadratic. Okay? Any questions on number 1? Very good. Number 2. Now they're going to get a little bit more complex. This time our a is not 1. And so we're going to be forced to move away from that easy factoring method into a more complicated factoring method, or the quadratic formula. The line of symmetry, how do we find it? So we're going to say x is equal to negative b over 2a. So we have the opposite of our b value 5 over 2 times our a value of negative 2. So we're going to have a negative 5 over a negative 4. When you divide with the same sign, the answer is positive. So my line of symmetry is 5/4, which is 1 1/4. This is going to be a little more tedious, obviously. So we're going to go to 1 1/4 on the x, and we'll just have to guesstimate where a fourth is, and that's going to be really tricky to get in here with the smart board trying to go up and down, but we'll do the best we can. Okay. Something like that. I could have grabbed one of those dotted lines up there and made it perfect, I guess, but that wasn't too bad. So there's my, oops, yeah, that's it, positive 1 1/4. There's my line of symmetry approximately. To find the vertex, we know that the x of the vertex is the same as the line of symmetry x. So if we plug that in place of x in our equation, we will get the y of the vertex. So to get the y of my vertex, I'm going to have y equal -2 times my x of 5/4 quantity square plus 5 times 5/4 minus 3. I just replaced the x in both places there with its value 5/4. And so we're going to get y is equal to 25/16 times -2. Let's just work it out. -2 over 1 times 25/16 when you square it, plus 25/4 minus 3. That's going to get complex. If you just want to punch it in and hit enter, that's fine too. What do you get? 25/8. You can do the math. If you want to do the math, do the math. You'd have to get a common denominator, right? So you'd have to convert the fourths to sixteenths and all this fun stuff. So 25/8 is the -25/8, thank you, is the y of the vertex, -25/8. 3/8 are 24 with 3 left over, so it'd be like -3 and 3/8, -3 and 3/8. So the vertex is at -3 and 3/8 for y, which would be 1, 2, 3, and 3/8, somewhere about right in there. Okay? It's not quite a half. I'm having trouble getting where I want to be, but we get the point. It's somewhere in between that big old blob. That was very not good. Let me try to do something here. I'm going to grab a color and just kind of put it about where it goes, maybe right in there. I should use my mouse more when I'm trying to pinpoint stuff, but then I end up doing that and losing it all. I'll try again. When I try to, oh, that was nice. We can see that one. Okay, we'll leave that one there. All right. So, is the vertex a maximum or minimum? A is negative, therefore it opens down, therefore the vertex is a maximum. You understand that? To find the x-intercepts, we let y be 0. Yes. The 25 is, it's not -25/8. It's supposed to be what? -1/8. -1. It's +1/8. Ooh, should have worked it on out, huh? Okay, so that's +1/8. Let's go back in and redraw that. So we'll grab a dotted line. We were at 1 1/4. That's about right there. That makes that a little easier to do. And then I'm going to grab the pen. Hopefully this is small. Let me test it out up here. That's better. And we're going to go up 1/8 from the So right in there, right, is my vertex. There we go. Thank you. Okay. Very good. To find the x-intercepts, we're going to let y be 0. And so we would have 0 is equal to negative 2x squared plus 5x minus 3. Now, we could factor using the AC method of factoring, or we could use the quadratic formula. This one doesn't look like it's being very pretty so far, so I would probably want to avoid that and use the quadratic formula, because if it doesn't factor, we got to use the quadratic formula anyway. If it doesn't factor, okay. So the quadratic formula, remember, is x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we're going to plug our a, b, and c into the quadratic formula to find the x-intercepts, which are the zeros of the quadratic. Everybody remember the quadratic formula from days gone by? No? So we need to remember that from Algebra 1 and Algebra 2. So x is equal to the opposite of my b value. It was a positive 5, so that makes it a negative 5, the opposite of b, plus or minus the square root of my b value, which is 5 squared, minus 4 times my a value of negative 2, times my c value of negative 3, all over 2 times my a value of negative 2. Now we need to know how to solve this down in case we have radical answers or imaginary answers, which is why we did 14a and b. So we would know how to solve down to those kind of answers, okay? So what we can do here is we can do this exponent, and we can do that multiplication, and we can do this multiplication on the bottom. I'm going to move it way up over here. So we're going to, I'll do one more step here. So we're going to have x is equal to negative 5 plus or minus the square root of 5 squared is 25. Now, when you multiply all three of those together, you're going to get 4 times 2 is 8 times 3 is 24. There's 1, 2, 3 negatives. When you multiply with an odd number of negatives, the answer is negative. You need to know those sign rules. When you multiply with an odd number of negatives, the answer is negative. When you multiply with an even number of negatives, the answer is positive. And on bottom, we get a negative 4. Let's see how we got that. The next thing that we can do is inside that square root, it's working as a grouping symbol. And so we're going to have x is equal to the opposite of b, plus or minus 25 minus 24 is 1, and that's over a negative 4. So that's where we're at. 25 minus 24 is 1. Remember when we undo the square with the square root, we get a plus or minus, and that's where that comes in. It's attached to that square root symbol. We're actually going to do the square root of 1 now, which is 1. And so we'll have x is equal to negative 5 plus or minus 1 over 4. Now, after you take the square root, that's where you're going to split it with the plus and then the minus, because it happens when you take the square root, okay? And so we're going to have x is equal to negative 5 plus 1 over 4. Or x is equal to negative 5 minus 1 over 4. Everybody understand the plus or minus and where it comes in? It comes in after you take the square root. Okay? So negative 5 plus 1 is negative 4 over 4 is negative 1. Negative 5 minus 1 is negative 6 over 4, which is equal to negative 1.5 or negative 1.5. Not sure. Do what? Yes. Say it again. Oh, why did this? Oh, I lost my sign of my 4. The question was, why did the sign of the 4 change? It wasn't supposed to. So that's a positive 1. And that's a positive 1.5. Thank you. I lost my negative on my 4. I thought you said something else, so I answered your question wrong. I know that was weird. Anyway, so now we want to plot those intercepts. So let me test that out. And so we've got a point at positive 1. There's one of my x-intercepts. And then we've got, I'm sorry, I missed. Because I forgot where I was. Okay, let's go back and find it again. I've got a point at positive 1, which is right here on the left side of the line. And then I've got one at 1.5, which is right here. Both of those are 1/4 of a unit from the line of symmetry. They're squeezed in pretty tight, okay? A little bit hard to see. So my x-intercepts were 1, 0, and 1.50. We use the quadratic formula to find those solutions. We could have factored that. Those weren't ugly numbers, so we probably could have factored using the AC method. How many remember how to use the AC method of factoring? Raise your hand. All right, let's do the AC method of factoring. We need to see it as many times as we can. So I want to go ahead and show you that because we just need the practice. The AC method of factoring a quadratic, step 1 is to multiply A times C. Multiply A times C. So what is the A of this quadratic? Negative 2. And the C of the quadratic is negative 3. When you multiply those, you get a positive 6. I think it's important to focus on the fact that the answer was positive. We're going to talk sign rules all the way through this process. If you can't quote your sign rules, they're on page 18 of the Algebra 1 book, and you need to be able to quote them word for word at this point. Now, what I want us to think then, the next part of the AC method of factoring, just so you know, and I probably should give you this reference, is on page 213 of my Algebra 1 book. And sign rules are on page 18, okay? 213 of the Algebra 1 book is the AC method of factoring, and page 18 is sign rules. Now, it says step 1, multiply A times C. Step 2, find all of the factors of the AC answer. So we want all the factors of 6, which would be 1 and 6 and 2 and 3. 1 and 6 and 2 and 3. That's step 2. Step 3 says, y'all watch this, step 3 says pick the pair that add to give you B using sign rules. Now, before we do that, we needed to say this. If this answer is positive, if I'm going to do step 2, it says find the factors of AC, I need to say my multiplication sign rules. When you multiply or divide with blank signs, the answer is positive. When you multiply or divide with blank signs, the answer is positive. What goes into blank? It's still blank. Same. When you multiply or divide with the same sign, the answer is positive. I know they have to be the same sign, right? Now I'm going to say my addition sign rules. I want to pick the pair that add to give me B, which is positive. So I'm going to say, when you add or subtract with the same sign u, how do you finish that? Add and take the common sign, add and take the common sign, which needs to be, so they need to be the same sign and positive, and I need to get a 5, so which pair does that for me? The 2 and the 3. Pick the pair that add to give you B using sign rules. So y'all really need to memorize sign rules tonight, word for word, okay, as they are on my page 18. The next step says to split the middle term into those two pieces. So we have our equation, y equal negative 2x squared plus 5x minus 3. We're going to split the middle term into those two pieces. So we're going to change the 5x into a 2x plus 3x. We did all of that just to figure out what to split that 5 into. We could have split it into an infinite number of things, but there's only one thing that's going to work for this problem, okay? And so we have y is equal to negative 2x squared plus 2x plus 3x minus 3. They say we got to that point. Let me review. What we did is we multiplied a times c. We found all the factors of AC. When we said our factors, we said when you multiply with blank signs, the answer is positive. Same sign. And then we said we want to pick the pair that add to give us B using sign rules. So we saw our sign rules. When you add or subtract with the same sign, you add and take the common sign, which needs to be positive, so they need to be the same sign and both positive, and the pair that gave us the 5 was the 2 and the 3. And so we split the middle term into those two pieces, 2x plus 3x. Everything we've done so far is just to get to that point of splitting it. We see how we got that. The next step says factor the left pair and factor the right pair. Factor the left pair and factor the right pair. What can we factor out of the left pair? Well, we'd like to take the negative off and the 2, and they have one x in common, right? You understand that that's what I can factor out? So we're going to think negative 2x times what is negative 2x squared? X. Negative 2x times what is 2x? Negative 1. We need to change the sign. Let's see what we're doing. We're thinking negative 2 times what would give me negative 2x squared? Well, I needed another x to get to x squared. Negative 2 times what would give me 2x? Well, I need to change the sign. So a negative 1. Okay? And then I'm going to factor the right pair. What can I factor out of the right pair? A 3. And so I think 3 times what will give me 3x? 3 times what will give me a negative 3? And I was hoping for a common binomial, which I got. Now, if I didn't get a common binomial, they would not factor, and I would have been forced to use the quadratic formula. Now, where you go from there is you write it as two binomials. The first binomial is that common binomial. The second binomial is the pieces, negative 2x positive 3, negative 2x plus 3. So it factors into those two binomials. Everybody see how we got that? Nope. See? Bring back from Algebra 1 and 2. Now, we set each one equal to 0, so we're going to say either x minus 1 equals 0 or negative 2x plus 3 equals 0. And we solve each one. So we're going to add 1. There's that one. So we're going to subtract 3. That's a 0 over there. Negative 2x equal negative 3. Divide by negative 2. X equal 3 over 2. That's that one. So that did factor relatively easy using the AC method of factoring, which we do need to know how to do, obviously. We're going to have to do that a lot before this course is over. Okay? Everybody see how we found the x-intercepts? All right? Now we want the y-intercept. I guess I should graph, though. I already did graph those. That's right. Yeah, we just found them again. I needed to show you how to do the AC method of factoring in case you didn't know how. We needed to start seeing that again. Okay? It's not about getting answers. It's about learning processes, right? I've heard that from Algebra 1, I'm sure. Anyway, to find the y-intercept, we're going to let x equals 0. So we would plug that in the x positions up there, which we might want to clean up a little bit so we can see. So we're going to have y equal negative 2 times. We're going to let x be 0 square. Plus 5 times. We're going to let x be 0 minus 3. To find the y-intercept, you let x be 0 in your equation. Now that wipes out that whole front part, and you just got y equal negative 3. That's pretty easy to solve for. And we could plot that point. Y equal negative 3, negative 1, 2, 3. I missed. Wow. That's not fun. Well, I'm going to give you, as far as grading the test, I'm going to give you some credit for each little piece that you do. No. I'm trying to get, right here. This is really giving me a hard time, and I can't hit the right spot. And I'm not on my pen anymore. I'm sorry, this video is going to not be as fun to watch as it could be. Okay, anyway, and so now we can graph, and the vertex was here, and it opens down, and it's a minimum, and so we got something like that, okay? Any questions on number 2? A lot of work, a lot of calculations we've got going here. So we'll stop there, and we'll have to have a part 2 recording, obviously. All right. Appreciate your attention. Thank you.